Okay, welcome back again. Here we'll take a look at some important components of VM encryption process, the KMS and the vCenter server. What roles do they play in this process? So first things first, you can't have VM encryption without having the KMS. And as we've just mentioned earlier, that KMS can either be registered with vCenter server. That's what we would refer to as standard key protection. But then there's also the KMS could be registered with the vSphere Trust Authority cluster, where in that case, you have a trusted key provider. We're focusing here on standard key provider, though, as in the example. So again, you need to have a KMS one way or the other, right? And this is a third-party software component, or maybe even a hardware component. Now, it does need to be compatible with the KMIP 1.1 protocol, industry standard protocol, and its goal here is to provide keys to the clients. Now, it says the client is vCenter. In reality, the client is the ESX servers, but the ESX servers don't talk to the KMS, right? The only systems that talk to the KMS are either vCenter with standard key provider or a vSphere Trust Authority cluster in the case of a trusted key provider. But the key server, the KMS, does not talk to the ESX servers directly. Basically, it registered with vCenter to be the interface, the vCenter server is the interface. vCenter will actually hold on to the key identifiers, not the keys themselves, and then the keys are then pushed down to the hosts by vCenter. Now, the KMS does work with a proxy server if you need to, and can work with IPv4, IPv6, or in mixed mode. To register the KMS with vCenter, first thing you'll have to learn from the KMS vendor are what is the actual registration process. The vCenter KMS registration wizard does offer several different ways you can register with the KMS. It all depends what the KMS vendor requires. Some vendors accept self-generated certificates. Other vendors require that the KMS generates a trusted certificate for the client, which then must be downloaded to the client. And other vendors accept only a client certificate provided by the KMS itself. Again, check your KMS vendor. And then the wizard basically sets the established trust, where you provide the cluster identifiers, fully qualified domain name, provide some credentials into the KMS. You set up the basic fill in the form to register with the KMS. And then the details, the credentials, and the keys are then, or not the keys so much, but the credentials for vCenter to authenticate with the KMS are stored in VEX. Now, the KMS is a critical piece in this whole process, right? Because it's generating the keys that will be used to encrypt the data keys, and the KMS is the only place where these keys are stored. So this is the most secure location here, right? Only authorized personnel should have access to the KMS. And generally, that should be a cluster of servers, because if the KMS server is offline, we just talked about earlier, if the KMS is offline when a server reboots, you're going to need to have to make sure you get that KMS back up and running. Otherwise, your VMs are all locked. So having a cluster to prevent a single point of failure is essential. I love the fact that we say the cluster must contain key management servers from one vendor. I can't imagine any software vendor would allow clustering of their software with another vendor's software in the same cluster. You'll end up having a cluster of KMS servers from the same vendor anyway. But yes, this is preventing the single point of failure. You point your vCenter server to one cluster. That becomes your vCenter server's default KMS cluster. And the cluster is identified in vCenter with the name of the cluster. So remember, what is the KMS doing? The KMS basically is providing one very critical key. It's called the key encrypting key. How you could also refer to this is it's a VM key, because for every VM, there'll be one key encrypting key created. So you have 10 VMs, you'll have 10 key encrypting keys. Every VM gets their own key encrypting key. And the purpose of that key encrypting key is to actually encrypt and decrypt the data encrypting key. Now, what's the data encrypting key? That's the key that is generated by the ESX servers to actually encrypt all the files that belong to the VM. And so the data encrypting key is there to actually encrypt the VM data. That's the only thing that is stored anywhere in vSphere persistently. But the data encrypting key is encrypted. So we encrypt the data, and then we encrypt the data encrypting key with the key encrypting key. The key encrypting key is never stored anywhere in vSphere. The data encrypting key is stored. It's stored with the VM files. It's actually in the VMX file, but it's encrypted. And finally, a third key, which is called the host encrypting key, right? The host encrypting key is used to encrypt core dumps. because the key encrypting key is in the memory of an ESX server, stored away in the secure key cache. So normally when an ESX server is up and running, there's no way to get access to the key encrypting keys that are held in your ESX server's memory. But if the server crashes and dumps core, well, then the key is probably quite visible in a core dump. So an ESX server's core dumps are going to be automatically encrypted to protect the keys. Right? So you have really three keys. You have the KEK, which is used to encrypt the DEC, and then you have the HEK, all right, the host encrypting key. Those, not all of them are managed by the KMS, right? 2 out of those 3 are managed by the KMS. Only the data encrypting key is managed by the host. But the host encrypting key and the key encrypting key, those are created and managed and stored in the KMS. The ESX servers only hold on to those keys in secure key cache of host memory. Now, what does vCenter have to do with all this, right? vCenter is not going to have any keys at all. vCenter is really the key handoff system because ESX servers don't have direct access to the KMS. Only vCenter has the direct access to the KMS. So the point of vCenter is to essentially establish the trusted connection with the KMS, manage the keys by their identifier only, and basically will pass and push the keys to the hosts. So the hosts, when they need keys, when they reboot, they'll have to ask for the keys via vCenter, which holds onto the keys by the identifier, so they can request for the keys on behalf of the hosts onto the KMS. Now, vCenter is also responsible for storage policies. So that's where we set up the policy for encryption. And of course, vCenter is where all the auditing takes place for any kind of events regarding any vSphere environment. And also, and we talked about this when we were talking about the vSphere Trust Authority, vCenter, when it is the key handoff system using standard key encryption, it can't itself be encrypted. If, on the other hand, you use the vSphere Trust Authority, now that case, the vCenter server is not part of the key handoff, and then vCenter can be part of the encrypted protocols, right? vCenter can be encrypted if you're using the vSphere Trust Authority. As we're discussing here, this is using really standard key providers, which means they're registered with vCenter. vCenter is a key dependent in this, and so vCenter cannot be encrypted in this method. The only way you get to encrypt vCenter is if you're using the Trust Authority. So vCenter and the KMS are that one system of trust between the two, right? The vCenter server is the KMIP client, storing all the key credentials the KMS credentials in the VEX repository. And of course, we're going to be using TLS 1.2 over an encrypted channel while communicating with the KMS server. So let's take a look at the process here, right? Now that we've been talking lots and lots of keys, remember the KMS is going to generate 2 types of keys, host encrypting keys and key encrypting keys. Now, in order for a ESX server to encrypt VMs, the ESX server must be placed into what's called crypto safe mode. Crypto safe mode simply tells the environment that the host is ready to encrypt its core dumps, right? The host has to be ready for that before it can actually run any encrypted VMs. So basically, when the administrator, the first administrator says, I want to encrypt this VM, well, then every host in your DRS cluster must transition into crypto safe mode before we can even start running a VM. So what does that mean? Well, that means that every host needs to get their own unique host keys so that every host knows how to encrypt their own core dumps. That's really the first step here, right? So the user performs an encryption task, creates an encrypted VM, for instance. vCenter server will request separate key from the KMS for every host in the cluster. These host keys will be used to encrypt core dumps. vCenter will retrieve the host keys from the KMS and push a host key to each host in your cluster, and the hosts will then install the host key in its memory key cache and enable core dump encryption. The host key is used to encrypt those core dumps. Once every host is in crypto safe mode, well, now we're ready to start encrypting a VM, right? Because that's what happened. The admin decided he wanted to encrypt a VM, so we had to first transition into crypto safe mode first. And now we can start encrypting the VM. So remember, what has to happen is every VM that's to be encrypted needs to have their own key. So the KMS generates a key encrypting key for this specific VM, and the vCenter server will make sure every host in the cluster will get that key. You say, why does every host get that key? Well, because what if the VM migrates from host to host? Every host needs to be aware of what the key is in order to encrypt and decrypt the VM's data key. So that's one key per VM. So the KMS will give the VM key to the vCenter server, and vCenter server will send that key to every host. The key is never stored on vCenter, only the identifier of that key. So once every host has the key encrypting key, it is now time to actually use that key to encrypt the data encrypting key. So that means that, first of all, the host has to generate a key to encrypt the VM data. So that's really what happens next. The host is going to generate its own data encrypting key, which will use to encrypt the VM and all of its disks. Then the host will use the key encrypting key for that VM to encrypt the data encrypting key, which the encrypted data encrypting key will be now stored in the VM's configuration files. And now we have an encrypted VM. So that's this bit. We'll take a quick break. We'll come back and talk more about the overall configuration. So we'll see you in a little bit.